What is alkynes and how they reacted and exactly what can do with them? The alkynes are hydrocarbons which contain carbon-carbon triple bonds. Together with their general formula, which is the CnH2n2 for molecules with one triple bond and no rings. Now, what is alkyne and its properties? Alkynes are nonpolar or unsaturated hydrocarbons with the physical properties similar to alkanes and alkenes. Alkynes dissolve in organic solvents, have slight solubility in polar solvents, and are insoluble in water. Compared to alkanes and alkenes, alkynes have slightly higher boiling points. Now, what is alkynes also called? Alkynes are traditionally known as acetylenes, although the name acetylene also refers specifically to C2H2, known formally as ethane, using IUPAC nomenclature. Like other hydrocarbons, alkynes are generally hydrophobic. How alkynes are formed? Since alkynes are frequently prepared through a double E2 reaction using two halides that are vicinal, meaning on adjacent carbons, or geminal, meaning on the same carbon. The reason for this one is because the E2 reaction takes place. Twice bonds are formed, and thus creating an alkyne. Now, what are the two types of alkyne? There are two classes of alkynes, the monosubstituted or the thermal and the disubstituted or the internal. If the triple bond is between two carbons, then the alkynes is internal. If it is flanked by hydrogen and carbon, it is a thermal alkyne. The principal reaction of the alkynes is addition across the triple bond to form alkanes. So in this video, we'll do a quick introduction to alkynes reaction. So alkynes are very versatile when it comes to synthesize and heterosynthesize. So it's important to understand why and how they reacted and exactly what can do with them. Again, an alkynes is a molecule that has a carbon-carbon or a triple bond which is written out as a carbon with three lines, but remember that the three bonds consist of one sigma and one 2 pi bonds. The pi bonds exist in the y or up and down plane and the z or forward and back plane to have a 2 pi bonds forming between the same two carbons. We have to combine one s and one p orbital to give us an sp hybrid, which means the molecules has a 180 degrees bond angle. Now, if we look at these two carbons here, the gray line between them would represent the sigma bond. In the white plane will show the p orbital going up and down, and then when these overlap, we get first the pi bond, and the z plane will show other p orbital, with the dark blue represents coming forward out of the page and the light blue represents going back into the page. So, pag kinikay mag-overlap, we get the pi bond and the z plane. So, ang carbon that having 4 orbitals saving the y and p zp orbitals for pi bonds. We left with just on s and 1p that fuse together, making the alkyne and sp hybrid, making the alkyne a linear molecule with a 180-degree bond angle due to the sp hybridization. Unya, pag sa line structure, kanang you just draw lang the a straight line and then two additional bonds, remembering that this one carbon and that's your second. So to name an alkyne, you add y and e to the end. For example, ang ethine is the smallest alkyne and is simply H and C triple bond, C with another H. So ang common name po ni ethine kay is acetylene. And you do have to memorize this one. It's because It will show up over and over again. But what makes the alkyne so exciting for reactions? The first is the fact that alkynes are acidic. A thermal alkyne is one that has the alkyne at the very end of the molecule so that it ends with the hydrogen rather than this end which has carbon. Meaning hydrogen there is sa taas is a fairly acidic where acetylene as we saw above has a pKa of 25. Tapos, ang pKa mag-changes siya slightly depending on what else is on the molecules. But 25 is the general range. It's not too acidic, but it's definitely acidic enough to participate in reactions. For example, in the presence of a strong base like NaNH2 where Na plus is positive, spectator leaving us with the amide ion NH2. Ang amide will reach out for it and grab the thermal hydrogen, giving acetylene back its electrons and forming the acetylene anion along with NH3 and solution. The acetylene is a good nucleophile and a key to your retrosynthesis arnisal. Kay pwede man nimo ma-use ang SN2 reactions and chain elongation. So what else can we do with alkynes? If you're not giving an alkyne, no problem, just make it. You can make alkynes from vicinal or geminal dihalide. For example, here we have a geminal dibromide, and in this presence of a strong base, we can get a double eliminations which give us 2 pi bonds. Forming between these 2 carbons of an alkyne, we can also start with a vicinal dihalide. In this case, we have chlorine on 2 neighboring carbons, and in the presence of a strong base, once again, will give us an alkyne. Say we don't actually want the alkyne, but instead we wanna use it as a stepping stone for other reactions. That's perfectly okay. This video has a quick fly through, hopefully to show you how exciting this is rather than make it overwhelming, and this will show you why it is such an important tool to have in your synthesis and retrosynthesis arsenal.